Good morning and welcome to Math 8's lesson for today, and that is going to be 3-3, comparing linear and nonlinear functions. So if you have me for class, this is about the third page through the note packet. Look for the title 3-3, compare linear and nonlinear functions. We're going to start there today. So today we've talked about functions, what they look like, whether something is a function or not. And remember that linear means it has a constant rate of change and that it graphs a straight line, and nonlinear is everything else, not a constant rate of change, and any other line that is not straight. Okay, so we're going to start some examples here, and you'll notice that right away I've highlighted a word, rate, or rates, and we're going to talk about that in this first example. So, an auto assembly factory needs to purchase new welding robots. The factory manager has information on two different models of welding robots. How do the welding rates for the two robots compare? Okay, let me remind you that rate also means slope. And so, in the last chapter, rate means slope. We learned how to find a slope. And actually, it's going to be the same way here, only we're going to have a lot of story problems here. So let me remind you what the formula is when we're using a table. So on a table, to find slope, we do y2 minus y1 divided by x2 minus x1. Okay, so here's our table here. We've got our time versus our number of welding tracks. And so what we want to do is realize that this is always our x side and our y side is on the right. So this would be our first x value, x1. This is our second one, x2. And we have more that we can use, but we're just going to use the top two. And then this would be y1 and y2. And so you might need a calculator for this, and I'm going to get one out to show you the buttons to push as well. If you are at home, you can use your Chromebook or you can use your phone and use that calculator. There's no graphing or anything you need here. So in this case, our y2 is going to be 52 minus our y1 is 20.8. And we're going to divide that by 5 minus 2, x2 minus x1. Okay, so on here you want to make sure you do this separately. So 52 minus 20.8, you want to get that answer first, 31.2 on the top. And then 5 minus 2 is going to give us 3. And now for a rate, we want to divide, okay? So 31.2 divided by 3 is going to give us 10.4. A lot of times in the last chapter, we just left this a fraction. When we're doing rates, sometimes we're going to end up with decimals. So what this means is that our rate here is 10.4 welding tasks per minute, okay? So we're going to write that in, tasks per minute for this robot, because we're trying to compare something in real time, in real life. Okay, now on the graph on the other side, let me remind you how we found the rate or the slope on a graph. We used rise over run. Okay, now remember the rise value is the up or down value, and the run value is going to be our right or left value. So this one, our up and down value, and if you can't see it, that says 11.2 going this way. So our rise is 11.2, and going the right and left direction is 1. So 11.2 divided by 1 is simply 11.2 tasks per minute. Okay, and so the question is, how do the rates compare? The model on the right is going to be faster, more tasks per minute than the robot on the left. And so if they want to purchase new ones, I'm assuming they're going to want to purchase the faster ones. So this one is faster or greater than this one. Okay, so this would be the one to purchase over here. Okay, cool. So the next example is going to be talking about relationships. So, and the next one is properties as well. And these are very similar, same words, or different words, I'm sorry, but same sort of strategy. So you might need to pause the video here. We're going to work with these three things to compare relationships: linear, nonlinear. If it is linear, we need to find the rate. And then what is our starting value? Okay, so in this case, this is what they're talking about. A square has side length S. The table shows the relationship between the side length and the perimeter. So perimeter, remember, would be the distance around the square as the side length increases. The graph shows the relationship between the side length and the area. Remember, the area is the middle part. How do these two relationships compare? So what we want to do for each of them is decide, first of all, is this linear or nonlinear? And on a graph, that's pretty easy. You can take a look. It's got a curve on it. So this graph for area is, non-linear. Okay, so that's the first thing. Over here, it's a little harder to tell whether or not a table is linear or nonlinear. So what we have to look for, we can either graph all of this and see if it makes a straight line, or we can look to see if it has a constant rate of change. Well, this side over here is constant. This, it's going up by 1 each time. Every time the side length goes up by 1. But this side, this went up by 4, and then this went up by 4, and then this went up by 4, and then this went up by 4. So this side is a constant rate as well. So this is what I mean by constant rate. Our rate is our change in y over our change in x. So our rate here is really 4 over 1, and that's the same every single time. So this, we say, is linear. Okay, so our next question, if it is linear, then we have to find the rate. Okay, so this one's nonlinear, so we can't determine the rate here, but this one is linear, and we just figured that out. I cheated ahead, I guess. And our rate here is 4 over 1, or just 4. And then the last thing we want to do is talk about the starting value. So in this case, the starting value at 0, right? If the side length is 0, the area is 0. So starting at 0. This one, if we look at our starting, if the side length is 0, the perimeter is also 0. So this one also starts at 0. Okay, and so that's how we compare the relationships. This one's linear, or this one's nonlinear, this one is linear. This one has then a constant rate of 4, but they both start at 0. Okay, let's do it again. Last example for the video then. So example 3, this is without any sort of story problem on it, but we're going to use the exact same things when we're talking about comparing the functions. So this one says compare the properties. Those properties are the three things we talked about above. Linear or nonlinear. If it's linear, what's the rate and what is the starting value? So in an equation, let me remind you from last chapter what is what. So remember, we used y equal mx plus b last chapter, where m was our slope, and I should have left more room, sorry about that, and in this case, we call that a rate, so our slope or our rate is m, and b is our y-intercept, that's also known as our starting amount, or initial value. Okay, so when we're doing our three things then for function a in this case, anytime it is in this format, y equal mx plus b, and there are no, maybe we should write this down over here. So let's write a note, okay? So in an equation, if you have that, if it's linear, they can have no exponents higher than 1. So technically, everything has an exponent on it. that is 1. For an equation to be linear, I should write. And also, we can have no variables in the denominator of a fraction. Okay, so anytime that you have either of these two things, it's automatically non-linear. So no exponents higher than 1, no variables in a denominator of a fraction. So function A is written in our format that we're used to, y equal mx plus b. So this one, first of all, is linear. Second thing, what is our rate here? So our rate is the number that is next to the next to the x. Excuse me. Whew. So our rate is 2. And our starting amount here is our y-intercept. And so let's not forget that the starting amount is not plain 3. That minus sign goes with a 3. Our starting amount is negative 3. Okay, comparing that to function B, this one, to determine if it's linear or nonlinear, if you have a graph, you simply look at it. It makes a straight line. This one is linear. Our rate this time, we need to find the rise over the run. So we need to find 2 spots. Now it's a little hard because there's no dots on here, but we definitely have a spot here on the 4. And we have a spot here on the 5. So what we're going to do is start at that 5, and our rise then is going to be down 5, so that would be negative 5, and our run is right 4, so our rate is negative 5 over 4. And then our third thing we needed to talk about was what is the starting amount? And again, that's the y-intercept. So where does this cross the y line? It crosses right here at 5. So starting amount is 5. All right, and those would be the 3 things you do to compare the properties or compare the relationships. Now, the way you determine which one you have to do, if you have to do all of them, it's going to say relationships or compare properties. If they only want the rate or the slope, it will specifically say rate or slope in it. Okay, hopefully this is helpful. If you have any questions, please feel free to email me and I'll get back to you as soon as I possibly can. Hopefully you have a great day and I will see you soon.